Okay, this is my next project, and it's going to be about Bayes' theorem, and actually it's about creating a calculator for Bayes' theorem to make it a lot more interesting. So this is the first of 3 videos on this, and if you want to know more about Bayes' theorem, why it's neat, Veritasium has a great breakdown on what it is and how it's used, and I've put a link down in the description below this video. So I want to make a Bayes calculator, so I want to be able to enter the parameters shown here into kind of something that looks a bit like 1920s, say, lab equipment, or sort of crossed with steampunk, and so I can sort of get more hands-on, change the probabilities and see the results straight away. And I'm going to do this in 3 parts. So like I said, this first part, that's going to be about Micropython and the UI to be able to control each of the rotary encoders and display the results on an OLED in kind of a nicely formatted way. I want to get that together so I can define the class to do that for one rotary and OLED combination. Then I need 4 of those, so I can just roll it out 4 times to use the class for the 4 input parameters. Part 2 will be about making the cabinet, so a little bit of carpentry work where I make an oak cabinet for it, put a brass faceplate in, and try and make it look as interesting as possible as something I can hang up and remind me what Bayes' calculation looks like. And then part 3 will be any final assembly. I don't think there'll be much, and then showing examples of using my Bayes calculator to calculate some things, and that should give a feeling for why Bayes' theorem's kind of neat. Okay, here's the design work for my Bayes calculator. It's not that complicated, so it's more about making something that I can hang up on the wall than being a really complicated design. But the idea is, first I'll get one of those canvas prints of the Bayes theorem, so kind of the P A given B equals probability of B given A times probability of A all over probability of B. That's Bayes' theorem. So get that on a nice canvas print, probably white letters, black background, and then I'm going to put that in some sort of box here, get a big brass plate on here for the actual calculator, have 4 rotary knobs and 4 LED displays for entering these values. And the reason for 4, I have a big display for the output, and then I have some switches on here for changing modes and be able to enter things as probabilities or decimals, and also be able to switch the modes. So quite often, as well as using this form of the Bayes theorem, sometimes there's a longer expansion of the values down here, so sometimes you need 4 values to calculate when you use that version of the theorem, and I'll go into more details about that. So I'll be able to switch the mode and enter 4 values or 3 values depending on what version of Bayes' theorem I'm using. That should be it. I'll try and give this some sort of steampunk look, so have a nice woodwork around the outside, brass here, whatever other thing I can do to make it kind of look like a traditional type of lab piece of equipment from maybe 100 years ago. And otherwise, first thing I'm going to look at is the code for these rotary input knobs and the display. So kind of what that's going to be is have a rotary input knob, and that's going to have 3 outputs, so a couple of them will be used to determine the direction and the value of the rotary knob as I turn it. Third one will be on the actual knob to activate a switch, so when you push these knobs it activates this 3rd value here, and I'll be using that to switch through the which values in the value in here I'm adjusting, so the first value, the second value, the 3rd value of the number. So say if I'm putting in 100%, I can start with setting the 10s and then the 1s and then the tenths by clicking through on the knob. Just make input easier.
And these displays here will be I2C, so I need to have these work in coordination with the knobs. This will all be running on a Raspberry Pi Pico microcontroller because it's got lots of I/O on it. It's got a couple of I2C buses, so I'll be using the I2C buses to run these. Each of these, the ones I have for the displays, can have one of two values for the addresses. So with two buses, two addresses on each, I can control 4 of these, and then this third larger display will have a separate address, so I can run that on one of the buses as well. So that should all work. So the first thing I'm going to be doing some prototyping on is getting this knob display combination working into the microcontroller. I'll probably set that up as some sort of Python function so that I can apply it to each of these 4 rotary controls and displays here, because they'll all be doing much the same thing. So once I've got it working once, I'll be able to use it for all 4 of these, and that'll be most of the work, because otherwise the actual calculation is pretty easy. So I just get some Micropython code to do the calculation based on what these inputs are set to.
And here's a cleaner render of what I think the Bayes calc will look like when I put it in a cabinet.
Got some of the main pieces together now. So this is the canvas Bayes Theorem. I just ordered that online. Looks pretty good. It's all framed up, ready to go. This is the brass front panel. It's a pretty heavy piece of brass. We'll have 4 of these rotary controls and displays down here. I'm just showing some just to make sure the layout kind of looks like it's going to fit on okay. This is going to be the main display here. There's going to be cutouts in this brass panel, and everything will fit behind it. I'll put some switches on here for changing the mode and things, and then the other pieces I'll make an oak case around it, so it's going to be these sort of pieces, and make as nice a case as I can to go around the outside and varnish it and things.
So I'm going to keep all the Micropython code and Visual Studio code and up on GitHub. So I'm going to create a new folder under my project folder. I'll call it Bayes Calc. And that's the main folder for any of my project code. I'm going to start off, I'll just make a dummy readme.txt file so I can put that into Git and GitHub. Okay, so I'm going to tell it I'll put the whole thing in a GitHub repository. So that's my first commit, and let's just check up on GitHub that everything arrived. Okay, so it should be ready to start. I need to change the addresses for 2 of my OLED displays, so I'm using a rework gun here to heat up the surface mount resistor here that switches between the 2 addresses that the OLED device supports. So just heating it up. I got the gun set to about 300 degrees. It took about 15 seconds to melt the solder. There you see the resistors moved, and then I can just place it in the new address location, heat it up, and the address has changed. So I wanted to test out a few things before I started. So I set up a Pi Pico, connected up a couple of OLED panels with different addresses on them, and an LED panel. So I wanted to test out the libraries I'm going to use. So I'm using this SSD 1306 library and this machine I2C LCD library. The 1306 library is for these panels, and the LCD libraries for this. First thing I did, I just wanted to set up a shared object that represents the I2C bus, or bus 0. So that's what I did here. And then I used this object
and initialize two objects that represent these two panels here, OLED 3D address and OLED 3C address. And then I also set up an object to represent the LCD panel here, which has an address of 27. Then I just go through a loop that has a 1 second delay within the loop, and it's just sending different messages to each of the panels and the LCD. So that should be ready to go. Let's connect up and try running this test program. There we go. And we can see here all the panels are being addressed individually. It's got different messages depending on which panel it's sending the messages to. So that all looks good. So I can get on with creating a class that's going to manage the rotary control in one of these OLED panels. To be able to use different fonts in my OLED display, the default SSD 1306 library doesn't allow you to use different fonts, so I had to use this Micropython font to Pi utility. You can find it out in GitHub, and the instructions for its use is there. One thing I found, it was easier to run this under Linux rather than under Windows. So after installing it, I'm in the directory that I put all the install files to. You run this as a Python program, so it'll be a Python 3. That's the utility font to Pi. So it creates bitmaps of based on true type fonts. I say I want it to be horizontally aligned. That's what the /x does. I say I want to start at ASCII character 32, which is the space, and end it at ASCII character 57, because I'll only be using this to show large numbers, so I don't need all the characters, so I can save a bit of space. And then that's the output bitmap files that I can use to render the numbers on the OLED. So let's try running that. So it looks like that worked. So I'm going to bring that over and then continue using this this font file, or this bitmap file in my VSCode application to show larger digits. Okay, here I am testing out that variable font size for the OLEDs that I have here. The new things are I'm using this writer library and setting up the I2C interface and the OLED for that particular address. I'm writing the prompt at the top part of the screen, putting a lot of a horizontal line across, and then writing the actual value, and this is all just test stuff to try it out. So let's see what that looks like. So there you see it there. So it's got the prompt up the top, horizontal line, and then it'll display the actual value here in nice big font. So that looks like it's working, so I'll change this into a proper library I can use for all the OLEDs. So I'd had some false starts here. I just couldn't seem to get the rotary encoder class controlling the OLEDs when the interrupt came off the encoder to say a value had changed. They just didn't seem to mix for some reason. I couldn't work out why, so in the end I actually carved the classes in two, so made a dial class which manages the rotary encoder, so deals with me turning the dial, pushing the button and updating the value, and they all happen based on interrupts, so they start up and run independently. And then I created a dial-oled class which formats the value that comes off a rotary encoder and displays it on the OLED in the format that I want, and using different size fonts and things. So that's my updated class architecture. It seems to work, so let's have a quick look at an architecture diagram, kind of an architecture diagram really just to keep me sane, and then we'll have a look at whether it works or not. But basically the idea is I've got a couple of classes, this dial class, which controls the rotary encoder. So it does things like being able to set the increment, being able to press the button on the rotary encoder so it changes from incrementing by hundreds, tens or ones, so a quick way of setting the value. And also this other class, dial-oled, and that encapsulates a lot of what SSD 1306 OLED controller does, but it also incorporates this writer class, which allows me to write out using fonts other than the standard one. So for example, I use the font to pi routine to change a sans serif true type font into a 35 pixel high bitmap, which this writer can then write out as large digits. So let's have a look at this running. Okay, let's have a look at the dial or rotary encoder controller and the OLED classes working together. So this is a little test program I put together. Basically brings in the classes, sets up a I2C object for bus 0, sets up a couple of OLED objects using the SSD 1306 class, and then creates dial-oled on the two addresses there, which represents these two OLEDs. We've seen that before. And then I set up a dial 1 and dial 2, which encapsulates the things that I want to do on these two rotary dials. And they start running, and then I just set up a little tight loop here, and every 50 milliseconds I check the value of these rotary encoders and display them using this using the dial-oled displayer. So let's try running this. So I've got percentages shown on one OLED and decimal values shown on the other. And you can see I change them by internally what's 100 at a time. If I press the button, it now changes by tens. Press it again, changes them by ones. Press it again, goes back to tens. Same thing for the other one. So I think that's all working correctly. So that's kind of what I want. It also displays the particular value that's been entered in the top part of the OLED. So that's what all this formatting does. So I think that's good. I can have 4 of these across my panel on the front of my Bayes calculator to input the values and then display them in this loop, and also do the calculation and show the results on this this LED here, which should be everything I need. Okay, that's probably going to be most of part 1. Probably come back to the code maybe at the end of part 2 or beginning of part 3. But part 2 is going to be more about building the Bayes calculator box. I'm kind of a fairly much a entry-level carpenter. You can tell by all the Ryobi tools and things. But we'll see how we get on making that. Put in the Bayes formula poster and the brass front plate and get all that connected up. Then be ready to go for part 3, where I'll just finish off connecting things up and then do a little demo of what the Bayes calculator does and why Bayes theorem is kind of an interesting thing to know about.